Hi everyone, hope you are doing well. Welcome to week 5, Fire Safety in Construction, Part A. So could you please confirm that you can see my actually screen and can you hear my voice?
Yes, sir, we can see you.
Okay, thank you so much for confirmation. Okay,
Okay.
happy Monday and hope you have a great week ahead. So this week is about the fire safety in construction for the unit of the health and safety in construction. So I'm honored just to deliver two lectures for this week, week 5 and the week 6. And I have divided the fire safety in construction in two parts. Part A is for this week, and the next week I will deliver the part 2. And I should just clarify actually our outline for these two lectures. So I consider each session in two parts. The first part is just giving you some basic knowledge and giving you some overview, some introduction about the fire safety and importance of the fire safety in construction. And the second half of the class is considered for practical actually aspect. It means that training you for software is a fire dynamic simulator or the FDS software that is very popular and well known in this field of research. So let's get started. I think it's good just first I initially introduce myself. My name is Jawad. I have a mechanical background and I have a PhD from the Mercury University. And also currently I am a research fellow at the School of Engineering, Mercury University. I have over 6 years of the experience in the energy industry as a senior engineer and a project coordinator. When I say that energy industry, I mean that the thermal power plants, solar power plant, refinery plants, and also the NGL plants. And specialized research interest in energy efficiency and decarbonization. And also proficient in computational fluid dynamics and the machine learning tools. The computational fluid dynamics is the term that I will use that maybe this week and also the next week. And actually the initial is the CFD. It's a method for solving some physics. Let me just introduce the references that I have used them for preparing these two lecture notes. The first one is the fire safety engineering design of the structure. This book actually provides a comprehensive coverage of the fire safety engineering principle and practices. It includes the fire risk assessment, fire dynamic, and the design of the fire protection system. And the second one is the principles of the fire risk assessment in building. Actually, again, this book covers the fundamentals of the fire risk assessment in building, and it includes the methodology, case studies, and the practical application. And the third one is the handbook of the fire and explosion protection engineering principles for oil, gas, chemical, and related facilities. Actually, this handbook covers some industrial facilities, some notes about the industrial facilities, and also offers some valuable insight into the risk assessment and protection strategies that can be applied to high-risk buildings. And the last one is the AS 1851 or the Australian Standard 1851 that is well known and actually is widely used in Australia. It's about the routine service of the fire protection system and equipment. This standard sets out requirement for the inspection, testing, preventive maintenance, and the survey of the protection system and equipment. And let me just give you the reason of choosing these four references. As a person that I have experience in industry, when we need some information about something, so we can just refer to some reference book or the textbooks, and even we have access to some handbook. The handbook generally covers some practical aspect and practical application that are very useful. And also the other one that is really valuable is the standard or the code. We have a code, and under that we have actually various and heaps of the standard. So in Australia, we have the various standards, and one of them is the 8051 that, as I mentioned, is about the routine service of the fire protection system and equipment. And so as someone, if you are interested in this field, so you have to become familiar with this standard. So this standard, as I mentioned, provides any details that I will just discuss them later. So let's get started with a very brief introduction about the fire. But before that, I think it's good just talk about the fire safety and the importance of the fire safety. So and then I will be back to this concept. But very quickly, when we say that the fire safety, it means that we need to consider some precautionary measures because we have two scenarios. The first scenario is that just minimize the risk of the fire. And the second scenario is that when we have the fire, what we can do just to minimize for example, destruction and some consequences. So the fire safety can be ensured if the flammable material are kept away from the heat and oxygen. From the high school, everyone knows that for just have a fire or just for to build a fire, so we need three elements. That one of them is the heat or temperature, the other one is the fuel or the material, and the third one is the oxygen. And these three together actually contribute to fire. So if we can just remove or eliminate one of them, it means that we have no fire. So we need just to control these three elements actually anytime. So as I mentioned, precautionary measures should be planned before starting any construction work. So here, as you can see, I have provided two examples, two massive and disaster fire around ourselves in our city and even in the populated area in the Sydney CBD. One of them is the latest one, and I see most of you have heard about that. It's the Surrey Hill fire, and the title was that the blaze got the heritage listed Sydney building. As you can actually meantime you can just watch the video on the right side. So on Thursday 25th May of 2023, so a fire ripped through a 7-story building on Randall Street in Sydney CBD that caused the former hat factory to collapse. It means that we lost one of our heritage building, and two 13-year-old boys actually charged over this disaster. So in the next slide, I have provided a detailed report about this. It was not, to be honest, a fire. It was an inferno, and everybody actually got shocked about this news. So the ABC actually provided a detailed report. So I'm just playing that, and I'm inviting you to watch this video. It's a brief video. I think it should be around the 4 minutes. You will actually get familiar with the different reasons and just the consequences of this disaster. So let's watch it. Okay, thanks for watching this video and hope you have found some helpful details about this tragedy. And the second one is again in the Sydney CBD, and it's about the massive fire at the Sydney's Barangaroo building site. So a large fire broke out on the March 11th, 2014 at the Barangaroo construction site while the workers were at lunch. So the Sydney's largest building project highlighting the drastic deterioration of the workplace condition in Australia. So the fire started around the 2 p.m. due a welding accident, igniting the flammable timber formwork in the second basement of the 39-story Tower 3. And so the blaze lasted for almost 24 hours. So I just mentioned these two examples, but if you are interested, you can Google it and you will see that frequently we have different reports of the fire in our cities, in our country. So it shows that the importance of the fire safety in the residential, in the industrial actually sites. So we have to be aware of them because in all of these actually catastrophes, these disasters, if they had considered all of the precautionary measures, definitely we would never have these consequences and these actually destruction events. So let me just also add this point that everywhere that you are, for example, now you are at work, you are, for example, at home, at your office, at the university, everywhere that you are. So we have the risk of the fire. And so as an expert, so you should just reduce the risk of the fire and minimize that because we can't just remove and reduce that to the zero. As I mentioned, it needs three elements. And generally, we have these three elements together, but we can just do some and set some precautionary measures just to reduce that and minimize this risk. So just introducing and giving you some basic and fundamentals about the fire, I think it's good just starting with the classifying the fires. So you should know that how many classes actually we have, and based on the fire, the class of the fire, so you can just select the best way to suppress them. And just, for example, to select the proper extinguishers or anything else. So with the class A is the ordinary combustible materials such as wood, clothes, paper, and the rubber. And exactly the question that jumps to mind is that how can I just suppress them? You can use only water. Through using the water, so you can just suppress this class of fire. The class B is the flammable or combustible liquid or flammable gases. So here you are not allowed to use the water. Instead, you need just to exclude air from the burning material. Just reminding you, we have three elements. So here, if you can just exclude the air, I mean that you can just reduce or exclude the oxygen portion. You mean you can just suppress this class of fire. The class C is the energized electrical equipment. They are very serious fires. So here we have the electricity, so we can use the water definitely for suppressing, and instead you can just use the electrically non-conductive extinguishing agents such as the gaseous system. If you have no idea about this type of the extinguisher, we will discuss that later, maybe at the end of this week or the next week. I will introduce a different type of the extinguisher. And the last one is a class D, is a combustible metal such as potassium, sodium, and the magnesium, and the other reactive metal. And how we can just suppress them through just heat absorbing medium, which is not reactive with the burning metal. After the classifying fire, so now you have some idea about the different classes of the fire, different groups of the fire. Now it's time, I think, to talk about the fire growth because actually the fire is growing through the different stages. The first stage, and also you can have a look at the figure. at the bottom. So the figure shows that the heat release rate versus the time. So you can see that we have a curve. When we have the ignition, it means that we are just starting the stage one. It means that the pre-flashover or the growth phase. And this stage involves a flaming combustion or a smoldering fire with substantial smoke, potentially leading to a spread of fire. At this stage, just gentlemen and ladies, only we have a source of fire. So if we can just realize and find that this stage very quickly through this the alert system or the warning system, so when we can just very quickly put it off. Otherwise, it just goes to the stage two. It's a flashover. It means that the rapid change from a local fire goes to one involving all combustible material in room. It means that it starts to spread in a room. So it means that it involves all of the combustible material around the source of the fire. And the stage three that is very, very destructive is a fully developed fire or the stable phase. So all material start to burn. The heat release rate depends on ventilation and the fuel quantity. So you can see that it's like a stable curve in the fully developed region. And after that, we have stage four. It means that almost material actually burnt, and we have the gradual consumption of the fuel in the compartment. It's a decay or the cooling period. So I will just refill and I will get back to these stages again when I am introducing the different, for example, extinguishers. As I mentioned, we have the different stage of the fire, and when we can't control that, when we can't suppress them, so the source of fire can spread. If it's internally, so it's spread through the non-fire rated doors, or even through the vertical shaft, through air duct, or through ceiling and the collapse partitions. So we have the origin or the source of fire, and if we can control that, so we have the spread of the fire. And again, if we can't control that, it means that it's spreading even to the other neighbors and other houses. Or if the source of fire is outside of the home, it means that it can just involve all of the houses and actually the neighbor. So after just introducing the different classes of fire, and different stage of fire growth, so it's time to talk about the precautionary measure that initially I pointed out. So again, we need just three elements for fire. So let's use up the flammable materials like the timber, bamboo, coal, and the paint, or etc. So we need just, again, we can't just reduce that the risk of fire to zero, but we can just minimize that. How? For example, you can just let's use up the flammable material if you can. Otherwise, you can just actually the quantities of the flammable material should be kept at the minimum at the work site. So if you have flammable solid or the liquid or the gases, so you must store them away from the oxygen or oxidizing material, just to remove the oxygen part or the portion. Or the smoking should be prohibited in the fire risk areas of the workplace. It's very important, the smoking. And one of the reasons initially was actually determined in the Baranguro construction site. The second example that I gave it to you, it was the smoking, but finally they determined that the main reason was just the welding. But smoking is very important and should be prohibited in fire risk areas of the workplace or any potential fire hazard. Precaution must be taken in transporting, storing, handling, and using flammable materials. And just it's worth noting that it's not always for conventional and fossil fuels. Uh, Definitely, I think all of you have heard about the energy transition and energy transition towards renewable energy. Still, in the renewable energy, we have the risk of the fire, for example, for the hydrogen, and we have the risk of the explosion. And we need, it's a mandatory thing that we always think about the precautionary measures for the transporting, for the storing, or the handling anything for the actually our resources. And also regarding the electrical fires occur due to the insulation failure, overloaded conductor, or poor connections. So proper care must be taken. So because of that, definitely in Australia, you need just to ask the electrician with the license to do some electrical stuff. And fire extinguishers should be kept at the strategically convenient point, and personnel should be trained to use them. Let me just explain that. In the at university, in the actually high-risk building, so we have always one person or a team, some personnel. They are trained for the case of the fire, and they will know how they can just use, for example, fire extinguisher or any ways just to suppress fire. And adequate water should be available to fight the fire. And one of the cheapest and easiest way is just using the buckets. Buckets filled with sand should be kept at the appropriate places to smoother the fire. So I mean that when you go to the servos, service station, fuel station, maybe you can see that these buckets. So I know that I talked a lot around the 30 minutes and I don't want to just make it very boring. So I'm really interested to engage you with this activity. Activity one is about the fire risk assessment. And this example actually comes from one of our references that I introduced you initially. So I think all of you have seen these high-risk building, this kind of the high-risk buildings. So we have a newly constructed high-risk building in a busy metropolitan area, such as, for example, Sydney's CBD, and it includes the commercial space on the lower floor. It means that like a shopping center, residential units on the upper floors or at the top, and we have a multi-level parking garage in the basement. So it's typical, and you have seen that definitely. The building is equipped with the various fire protection systems such as sprinklers, fire alarms, and the fire-resistant material. So the question is that it doesn't need any calculation, it doesn't need any math, and also I need only your time just to think about that. The question is that, however, we need a comprehensive fire risk assessment to ensure that the safety of the occupants. So I think it's time just to have a break maybe, but meantime that you are filling up your bottle or stretching everything that you like to do. So meantime, please just think about that. You have 3 minutes, and after that, I will ask you just please propose your idea and what do you think about just having a comprehensive risk assessment in these building. So yeah, take your time and I will be here in 3 minutes. And meantime, if you have any questions so far, I'm here and just I'm very happy to answer your question. Okay, please let me know, unmute your mic if you have any idea and share your idea with us. Any idea? Okay, I will explain them and then if you have any question, let me know. So as we mentioned, we have a new constructed building. So definitely, as it's mentioned also clearly here, we have a fire protection system. It means that we have a sprinkler, fire alarm, and the fire resistant materials. But as a fire risk assessment, if you are an expert and if you go to this building to visit this building and provide a report, so you need just to provide, just first check the potential fire hazard. So have a look at this slide, the next slide. You need just to find and identify the potential fire hazard of this building again. It means that reassess. So you need just to examine different areas of the building for potential ignition sources, such as, for example, electrical equipment, cooking appliances in the residential units, and the storage areas for the flammable materials. The second step is that assess the material used in the building construction and furnishing for flammability and potential fire spread. So first you need just to identify the hazard, and then you need just to assess the effectiveness of existing fire protection system. Because it was clearly mentioned, we have a fire protection system, but as an expert, you need just to assess the effectiveness of existing fire protection system. How you can do that? In two sections. You can just evaluate the coverage and functionality of the sprinkler system, smoke detector, and the fire alarms. If you have no idea about, for example, the sprinkler system or the smoke detector or fire alarm event, so I will just explain them later, but I think most of you are familiar with these devices. And also you need just to review the building fire resistance rating, including walls, doors, and the escape routes. So you identify the fire hazards, you actually assess the effectiveness and the efficiency of the fire protection system. And now based on these two steps, you can just provide some upgrades and some additions to the fire protection system. For example, based on your fire risk assessment, this building needs some new or additional sprinklers, or even we need just to upgrade the sprinkler system. It's not effective enough. And also you can just propose changes to building management practices like regular fire drills, maintenance schedule for the fire safety equipment, and training for staff and residents on fire safety procedure. So you can just provide some additions, some upgrades, some recommendation, and also you can change the frequency of the maintenance. For example, from every 6 months, or you can just change that to the monthly based on the actually the risk of the fire. If you see that is a hazard, so you can just change that, or even you can you maybe you found that okay, the personnel actually they are not qualified enough, so maybe you can just recommend to train them again or just run some additional training session for those people. So it's a risk assessment, a very simple risk assessment for example, high risk building. And also we have another type of this activity later. So I think now it's time just to talk about the fire detection and the alarm system. So the combination of the fire detection, the alarm system can detect the fire at the earliest stage and alerts people, hence life and the property could be saved. If you remember, I introduced the different stages of the fire growth, and I mentioned that if we can just detect the source of the fire at the initial stage, it means that we can just save the people's life and also their properties. And the fire detector is designed to detect one of these characteristics of the fire: heat, smoke, and the radiation or the flame. And the third point here is the type of the detector to be installed. So you need just to first identify the fire hazard, and based on that, you can just install the proper detector. So it should be placed or it should be installed at the place, depends on the nature of the construction and type of the hazard that might take place, as I mentioned. So I am introducing three different detectors. And if you look at the ceiling now, everywhere that you are, so probably you can see that one of these detectors. One of them is that heat detectors. So the fixed heat detectors respond when the ambient temperature reaches a high value of 58 degrees centigrade. So it works based on the temperature. And the heat detector measures the rate of the increase in the ambient temperature and responds when an increase in rate is above the normal or when the temperature or the ambient temperature reaches 58 degree, whichever is earlier. It means that it's only monitor the ambient temperature. So if the rate of the increasing the temperature is very high, or if the temperature actually goes up to the 58, it means that it starts just to detect an alarm. The second one is the smoke detector, and maybe you get confused between the heat detector and the smoke detector, but they are different because the smoke detector actually, as you can see in the figure, so the ionization smoke detectors respond when the smoke enters the detector and causes a change in ionization currents in the detector. An optical smoke detector contains a light source, and the photo electrical cell respond when light is scattered by smoke particles. And the third one that I think maybe you have not seen them because it's used in industry. So it's the flame detectors. It's a detector that looks over a given area and responds when it detects a UV or IR radiation. And because of its inability to detect the smoldering fire, like a smoke detection or a smoke or particles of the smoke. So it's used in a specialized application to supplement the heat and smoke detectors. Generally, they are used, for example, in the boilers. And as I mentioned, because of their inability just to detect the smoldering fire, so they need just to install along with a heat detector or the smoke detectors. So here you can see that the fire detection and alarm system that I have brought some points from the AS 1851 or Australian standard. So you can see that we have the different routine service schedules. So we have the fire detection and the alarm system, a special hazard system, and the smoke hazard management. So you can see that in the figure. The other one is that the smoke alarms and the heat alarms. So definitely you have seen them maybe at the university or at your building. The third one is that the emergency warning system. Maybe you have heard that, for example, evacuate now, evacuate now. So it's just for the alert the occupants. And the last one is the emergency intercom systems. It's for the case that you don't have access to the mobile or the telephone and you can have some communication. So you can use them, but actually the firefighting teams can use them or those people who were trained for this case. And here I have inserted two interesting example from the AS 1851. It shows that the routine service record So based on our actually the areas or the equipment, devices, and their importance, so we need just to do inspection frequently. For example, we need just to do some inspection and check them, for example, monthly, or for example, every 3 months, every 6 months, or yearly, or for example, every 3 or 5 years. And after just doing the inspection, as we can see in the left figure, so definitely we have a logbook. So the expert needs just to fill it up. And also they can maybe, if it's necessary, they need just to install a tag or the label based on the different devices. For example, for the fire hydrant system, only just filling the logbook is enough. And if you remember, we classify the fire. So we have, for example, the class A, B, C, D. And based on the different classes, we can use the fire extinguisher. Fire extinguisher is one of the effective and maybe one of the simplest way just to put up and quench the fire. But it's important to use the appropriate one. So if you have a look at here, for example, the case of the water, let me just change that to this. Okay, yeah. If you have a look at the water, so for just extinguisher includes the water. So we can only use that for the class A. It means that wood, paper, textile, or other uh, actually materials. So, but you can't use the water for anything else. But when you have for example, the CO2, it includes the CO2, so you can use that for the flammable liquid or the some spray. So based on these table, so we can just select the appropriate fire extinguisher and install them at the strategically convenient point. If you have any questions so far, please let me know. Okay, good. And here is a fire sprinkler system that I think we can just call it a day, and we can just keep that for the next lecture. I will just explain the different fire sprinkler system, and we can just start the second half of our session is about our practical part. So you have a 1 minute break, and then we can just start our FDS. So I need just to give you some introduction about the FDS, and then we can just do some running some actually examples. So take your time. After 1 minute, I will just start training the FDS. And Andy, thank you so much for your response. And sorry I didn't see that. Thank you for your feedback for our activity one. Appreciate. So guys, if you are ready, so we can just talk about our FDS. But before that, as I mentioned, it's just time to give you some details and overview about the reason of using, for example, the FDS. Yep, let me just. Okay, we have another question. I will just explain them later. Just let me just, because I started the second part, but at the end of the class, definitely I will just answer your question. Okay, so when we need just to model a physics in the real world, so we have different ways and we have different scenarios. The first one is just doing some experiment that you can see, for example, here. So when you need just to do some experiment, it means that that is, I think, the most valid method, okay? But the issue is that you have some limitation in terms of space, in terms of the cost, in terms of the time, even in terms of the measurement. But for example, you have the risk of the fire. For example, in this case, if you are studying the, for example, fire case, your case study is fire. Or for example, we have the risk of the explosion. For example, you need just to consider the health of the people. So you need to consider a lot of things, but definitely the final results are valid and they are expensive. For example, for the renewable energy that I am actually doing some research on that for the hydrogen, so it's very difficult to do some experiment because of the risk of the explosion, and we need actually the huge space and some advanced tools just for measurements. So it's very difficult, challenging, but sometimes it's worth to do that. The second one is the mathematical model. So, for example, as you can see here, we have heaps of the formula. For example, in the last lectures, previous lectures in this unit, so maybe you became familiar with the different formulas. And you can use them just to calculate, for example, the size of the dispersion cloud or anything else. But these formulas, while there are several and there are a lot in actually in the quantities, in the number, but they are very limited. They cover uh, limited physics, so you can't use them for every scenarios. Uh, for example, we have, for example, the force formula. So it's equal to the ma. It's a mass and acceleration. But when you are just simulating or you need to do some experiment or simulation, so actually they are not effective enough. The other one is the empirical model. It means that they come from some experiment and just through the data-driven model, some exporting the correlation between the different formulas and the data. So you can just extract some empirical models, but still they are limited to do some study. The fourth one is the statistical model. So you can do that some probabilistic analysis, uh, but they are not actually comprehensive enough for any other scenarios. And the last one that is our focus is the computational model or the simulations. So they are actually effective, they are valid, and so you can do any simulation, and the cost of the simulation depends on your case. So you need only some computational facilities and other actually things is that the computational time. So if you can just handle it, it means that you can just simulate anything that you like as long as your results seem look reasonable. You can see that actually the one of the simulation, FTS simulation in this figure. Okay, when our focus is simulation and computational models, so we have 10 different ways to do that. The first one is the commercial code. So the commercial code, it means that they need the license. You need just to purchase the license. For example, the flags is very good for just doing some fire analysis, or the ANSYS. It includes the heaps of the components such as ANSYS Fluent, ANSYS CFX, and it covers actually different fields. And PyroSim, the PyroSim is the commercial version of the FDS. It's visualized. You don't need to do any script or any coding. And the other one, for example, is the star system that is very powerful, but still you need just to purchase to buy the license. The second one is the in-house code. It means that you can just write your code from scratch, or maybe you can just develop a code in the different programming languages such as the C, C++, MATLAB, or Fortran. So you need just to some knowledge about the programming, and then you can just develop your code. You can just use the different governing equation, discretize them, in the programming language, but you need just to have some knowledge of this. And the third one is the open source software. It's like a FDS, Fire Dynamic Simulator, or the OpenFOAM. They are free, and you don't need just to buy any license, and so you can use them, but they need actually to do some script and some coding. Now I think it's time just to work and install FDS on your laptop on your PC. So if you have access to the lecture note of this week, I mean that the big part that is already uploaded, so you can just open the lecture note and click on this one of these three actually options if you use the Windows or the Mac or the Linux. So only if they are hyperlinked, so you can just click on them and one installer, FDS installer will be downloaded quickly. So from now on, if you have any problem, please unmute your mic and let me know. So, but if you don't have access to the lecture note, you need just only to actually pull up your browser and type the Fire Dynamic Simulator download. And you need just to click on the link that is provided by the NIST.gov. Please do that and let me know if you have any problem. So any problems so far or no? So once you downloaded actually the installer, so you need just go to your downloads folder and run the file. The name should be this one. It's the latest version 6.9.1 SMV 6.9.1. If you run it, maybe you face this message. If you face this message, you only need just to click on more info. And after that, it pops up and you can just select run anyway. Please do that and let me know if you have any problem. If you have access to your laptop, your PC, desktop, so please do that now because we expect that you will install that today. And because next lecture is we will work on actually a real world example and on tutorial. Again, we need just to work on another example. So if you complete these two steps, and you just press and hit the run anyway. Maybe if you use any laptop from the Mercury, or maybe you see that in the installation process, maybe you face this message. If you see this message, you only need just to click on the authenticate with your identity provider. Who is your identity provider? Is Mercury University. So if you click on this hyperlink, you need just to log in to your Mercury profile, and then you will see that it turns to the authenticated, and you will see that a green T next to that. Please do that and let me know in case you have any problem. No questions so far? Okay. So in the process of the installation, so maybe you see that this window, it pops up, and you should just type here yes. It means that the standard installation and use the default setting for all questions. Please type yes. And this command window, once you complete that, so you need just to reboot your laptop or the PC. But because we are still in the lecture, so please don't do that. And hopefully you can run that without rebooting. But after the session, please just reboot your laptop or computer. So if you see these messages, so it means that it's completed. Press any key, then reboot to complete the installation. Without and skipping from the rebooting, now we have the FDS folder content from the start menu. If you go to the start menu, and if you go to the FDS 6, under that you can see that several options. The first one is the CMD or the command FDS is a prompt window and is our main actually window to run our FDS case. And you can see that a lot of guide, user guide or verification guide, different and for the smoke view and for the FDS. So we need the smoke view, guys, because we need just to do some post-processing. I will explain them maybe this week or next week. What do I mean when I say that, for example, pre-processing, processing, or the post-processing? But generally, after just completing our running the case, our case study, so we need just to study the results and visualize them. This step is named actually the post-processing. So to do that, to visualize the results, we need the smoke view. And we call it smoke view and we will open our result. The thing that I will do that very quickly, very shortly today. Okay, so you can see that the FDS here, and just to run the FDS to check that it is successfully installed or not, you can just go to the FDS and select the CMD FDS, or you can go to the start and type CMD. You will see that this option, CMD FDS. So I will just do that now. Okay. Here, so if you just select CMD, you will see that because I have already installed this software. So here you can see that our main window, and if you type FDS, only FDS, So you can see that there are some details, some message. It shows that the version is installed on my laptop. So the MPI version and some details about the revision of the FDS. So please do that and make sure that your FDS is properly installed on your computer. Any questions so far? Please ask your question if you have any concern, if you faced any issues, any problem, let me know. Okay, good. So here I need just to provide some details about working with this window if you are not familiar. So let me just back to the here. So you can see that after just making sure and ensuring that, okay, you have the successful installation, that you should just see these details. So we are just going to run one of the example, built-in example in the FDS. So if you go to this directory, I mean that C program files, fire models, FDS, examples, and the fire. So let me just do that. I will go to drive C, program files, fire models. As you can see, we have two smoke view and the FDS, but here we need the FDS 6. And if you go here, now it's time to go to the examples. Here you can see that we have several examples, and I'm interested in the fire example, so I click on the fires. So you can see that we have different examples. The main file should be, the extension should be .fds. For example, I select the coach here. Copy that here and open a new window. For example, I'm just opening a new window. It depends on your space, but I'm selecting here. I create a new folder and I name that as a week 5 and I paste that here. And let's have a look at the contents. I open that with the notepad file software. So here I will just explain the contents next week, but very quickly here is the head of your script. So you need just to name, it's the ID that you need just to specify a name for that. I will explain that what is the mesh. What do I mean when I say you need just to specify the mesh of your domain? And here you name the different domains. As you can see here, it's the time of the computational analysis or the computational time. So it's 600 seconds. So it takes a lot of time and we need just to reduce that to actually maybe 5.3 seconds. But otherwise it will not be completed in our session today. And here you can see that each of them represent, for example, the devices. HRR, as I mentioned, is the heat release rate. So I will explain all of them next week. Here you can specify the material ID again. Here, this one shows that the surface ID, it means that you need just to specify some surfaces. Don't worry, I will provide that code for you and you can just use that and only you need just to change some values. If you are not very interested, or if you are worried about some coding and doing some script, don't worry, I will provide that. Only you need just to do some changes. And the main, our goal, the primary our goal was actually to make you familiar with this software. Because if you are interested in working in this field, in the actually job market, so you need to have some skills. So here you will become familiar with some basic knowledge and some overview about the fire safety, and you can just mention in your CV that I am familiar with, for example, the FTS. If you are familiar with the FTS, so definitely the PyroSim is a commercial version of the FTS, is very more straightforward, and you can just say that you can just work with that. I think most of students and universities can just get a 6 month license from the PyroSim. So you can just contact with the support team and they will provide 6 months free license if you do some research or if you are interested in this software. So then you can just even mention and add a new skills and in your software section of your CV, and you can claim that I'm familiar with the FDS and even I'm familiar with piracy. But if you are interested, there are heaps of the materials, resources, so you can just continue your training and you will definitely find a good actually position in industry because it's very popular. So here you can see that it shows that the obstacle, if you consider any walls between the, for example, the bedrooms and the kitchen, anything, so you need just to model the obstacles in your model. I will show you. And if you have any vent for the ventilation, so you can just specify the coordination and etc. So I don't want to just take your time to explain that. I will do that in the next week. So only please just change the computational time or simulation time to 5.3 seconds. If you do that, just please save it. Close this one, is open from previous. Okay, here. So we have the coach file. It shows that the birding coach in a room. So let's get back to the lecture note. If you do that, so you just need to create a folder. I named that coach, or for example, big five, it's up to you, it's not important. And just to run this case, you need just to pull up this CMD window or the prompt window. If you want to go to the specific directory, you need just to type cd space and just copy that directory, for example, week 5. I mean that the folder that contains and includes your coach FDS file. So I copy that, and if you right click here, or you can just Control V to paste that here. So the current directory is that C users my username. But now you will see that it will change quickly. Now it shows that the folder contains the FDS file. Okay, so again, you need just to copy the directory address, type cd here cd space, one space, and paste that directory. If you enter, so you will see that the current directory is changed. So just as I mentioned, the only thing that we need is just to change the computational or the flow time to the 5.3 instead of 600. And just to run your FDS file, you need just to type FDS space, the name of the FDS file dot FDS, that is the extension. Let's do that together. So FDS coach dot FDS. If you enter, okay, something goes wrong with my, let me just look at that file, coach FDS. Okay. Okay, FDS. Let me just have a look at that one. Here it should be the coach.fds. Let me just, if you type dir, it shows all of the contents here. Yep, so FDS, okay, we have, yep, okay, FDS coach.fds. Yeah, for some reason, again, we have some issue. Let me just have a look at that file. Just please do that with me. And if you have any problem, let me know. So we change only this one, so we can maybe remove that one. Okay, and we can save it. Yeah, it's running, it start to run. So it takes time. It should be around maybe 3 to 5 minutes. It depends on your system configuration. I'm using just only one processor, so you can just use that parallelly. And here you can see that the time step, so the first time step is the 0.1, and here you can see that the number of iteration. Now, if you remember, we set our flow time to the 5.3. Now we just completed the half of that, 2.52. Let me just close our FDS file. Okay. We have 70 iteration for 3.71 flow time. I highly appreciate if you do that with me, and let me know, please, for any issues or any problems. It's a familiarization actually session, and the next week we can do that one by one, and we will just write a script. Then we can just run our example. I will show you today our example, our next example, but we will do that later. Here you can see that the number of MPI processes, so it's just one. You can just use the parallel if you like, but I think just one is okay because we reduce the flow time to the 5.3. Yeah, it's completed. FDS completed successfully. And what is the final time? It's a 5.3 that we already set it. So now we have we completed our simulation. If you look at this folder, if you remember, only we had the coach.fds, but after running, so we have several files. It means that they are the outputs of our simulations. Any questions so far? Okay, so now it's time. The first step, let me just very quickly explain them. The first step that I opened that file and changed the flow time or anything that I like is the pre-processing. And the step that I ran it's processing. And now after the completing the simulation, the name of this process is the post-processing. So how can we do that? We can just type, let me just first show you on the lecture note, and then we will do that on my computer. So here you can see that this window, we just changed that to the 5.3. And now for just doing post-processing, if you type SmokeView, SmokeView is the name of the software for the post-processing. If you type SmokeView coach.smv, so you will see the results. So please do that with me. So pull up that one, smoke view coach dot f sorry smv, yeah, smv. So if you get confused, the name of the actually this smv file. So again, you need just to look at this folder and find the smv file. It's this one. So only you need just to type smoke view. It means that you call the software, you launch and open the software, and then you say that please read this file. So let me just explain that again. So here, when you say that the smoke view, it means that you are launching, you are opening your software. The name of the software is the smoke view. And then you ask the software just to read the coach.smv file. It's like anything for any actually analysis or simulation software. You open or the launch the software, and then you go to the, if it was visualized. So you go to the file, and then you read your case file or your data file. So I press enter. So here you can see that this example, it was a coach in a room. Here I provided some instruction how you can just handle it and how you can control the view. So you can just rotate or move through the left click and drag. And for zoom in and zoom out, you can just press Control plus the left click and drag. So let's do that together. So if I press the Control and through the left click, so we can just zoom in or zoom in or zoom out. And for just dragging, so you don't need just to press the Control, you only need or the hold the left click, and you can just drag it and position it at the appropriate view. So now you can see that the example, but it's actually only the geometry, but you need just to see the results. So if you go to the load, if you right click here, I provided the details here. To see the results, you need just to right click, go to the load or unload, and we have 3-dimension smoke. Please do that with me. Again, right click, load or unload option, the first option, go to the smoke view and go, you can just select, for example, the soot density. If you don't know what is a soot, soot is the results of incomplete fire. Again, let me just remind you, we need 3 different elements together just to have a fire: oxygen, material or the fuel, and also the heat or temperature. If we don't have sufficient oxygen or we don't have sufficient temperature, high temperature. So it means that we have incomplete combustion of the hydrocarbon, for example, such as, for example, wood, coal, or any material, flammable material. And as a result, we can see that fine black particles. So we name that as a soot. Okay, so I press the soot. Now you can see that the soot here, if we extend the flow time, definitely you can see that these black cloud or the soot particles will just spread all around and across the room, just due to the limitation of our session time. So I reduced that to the 5.3. And if we are interested in, if you want to unload the smoke, so you can just go to load, unload, 3D smoke, and go to the unload and select the soot density. It means that you unloaded it. If you are interested in the heat release rate, so you can just select this one. Here you can see that the fire, okay, we have a question. Okay, so I think, Adel, you forgot to change the flow time to the 5.3. So in this case, you need just only to close the CMD file and just change delete all of the contents except the coach.fds in your folder, created folder, and just open the coach.fds file, change the time to the 5.3, and then run it again. Is it clear? Okay, no worries. Okay, good. So here you can see that heat release in our example. Please do that and let me know if you have any problem. It's very interesting. I believe that the practical session should be more interesting than just some theoretical part. The theoretical part, but to be honest, is very essential because without that, you don't have any idea about about doing some analysis in your software. And I have provided these two parts together in each session. And actually, my aim was just make you familiar with the fire safety. And as I mentioned, if you are interested, you can just continue your training, and you will be an expert in this field. Okay, good. If you are very interested to see the suit and the heat release at the same time, so you can just follow the previous instruction. Now select the suit density. So at the same time, we have the suit and the heat release rate. Even if you are interested in the temperature, so you can go to the load or unload 3D smoke, and then you can go to the temperature. We can see that temperature. Even we can just consider some slice that we will do that next week, don't worry. And I will just create some sections, and on those sections you will see that, for example, the velocity or the temperature, anything that you are actually interested to see the results. Okay, let me just check our chat box. Okay, we don't have any question now. So here we can just unload the suit temperature. We can just unload the temperature event. Okay. Just to show you that, for example, here we can see that if we consider the slice, so you can see the heat release rate. Yeah, here we consider at the x is equal 2.55 meter. So we consider a slice, as you can see here, that we will do that next week. Let me just zoom in. Yep. You can see that actually the temperature. Even you can go to the slice and you can see that the U velocity, but unload the previous one, go to the load, unload option, slice again. It means that you consider some sections, some slice, and on those surface, you are interested in seeing the result on those planes. So for example, the U velocity, because it's a 3D model, it means that we have the velocity in three directions. X direction is the U, V direction is, Y direction is the V, and the Z direction is named with the W. So for example, the U or maybe the Y. So here you can see that the range of the velocity, it varies between these two values. So I unload all of that. So I'm zooming out a bit. If you go to again, we still have the different option. You can just do that by yourself. So you can see that the boundaries, well, I will explain them what I mean when I say that the boundary. Generally, in modeling, in simulation, we have two boundaries, the boundary condition or the initial condition. We have two conditions, sorry. We have the boundary conditions and we have the initial condition. I will explain them later next week, don't worry. But if you are interested in the vector slice, so you can just have a look at those values. Here you can see that if you zoom in, you will see that we have some vectors instead of magnitude, instead of actually the velocity magnitude. So you can see that the vectors. If you go to the other option, show or hide, you can go to the geometry, so you can see that different option is only show the outline. If I go to the grid and show the grid, so here when I say mesh, I mean that this part. I mean that in the CFD, computational fluid dynamics, we need just to discretize our computational domain into tiny or small cells. In this way, we can just actually solve our governing equation for each cell. That I will just explain them, don't worry. Even if you go to the geometry, to the grid, so you can see that, for example, you can just active all of them. Or here you can see that the grid again. So even you can just change the color bar because we have the different style for the color bar. We have the rainbow, original, linear, divergent. So you can just use one of them if you like, just to show the different colors, because each color represents the different values. Yeah, that's even you can just active the different labels. You can ask a smoke view just to show, for example, the time. Even you can just name some titles. You can see here, you can just activate them. Even you can just select the HRR. So you can just work with that and make it very interesting for yourself. So any questions so far, Urban? Take your time. You have 1 minute. After that, complete and wrap up your simulation. If you are still doing that, do some post-processing and let me know if you have any question. In this slide also, I have added this coach example. So you can see that the heat release rate and the salt. And if you are more interested in the built-in example, again, you need just to go to this directory, I mean that installation directory, and select each of them. For example, the box burn. So you can see that in the different scenarios or different, for example, the tunnel linear CP. So you can just copy that, create another folder, and go to that folder through the CD, the directory, and run the FDS, call the smoke view, and show and see the results. Okay. So for the next week, very quickly, I will just explain the fire sprinkler system. I will introduce. We have another activity, and after that, I will just give you. We can just consider the most of the time for the practical part instead of the theoretical part. Next lecture. So I will explain that the CFD or computational fluid dynamic part, you need to have some idea. I will talk about the mesh. I will talk about some popular commands in the FDS. And then we will work on some real examples. We will just model a building with 3 or 4, for example, bedrooms, and we consider a source of fire, and we'll study the soot or the heat release rate. And if we have time, I'm very eager to actually teach you how we can consider a water mist, a sprinkler exactly above the source of the fire, and you will see that the water drop above the fire and how it can just quench and put it off, or at least can reduce the amount of the soot and the heat release rate or temperature. So if you don't have any question, I think it's enough for today. Let's call it a day. Maybe next week we can discuss a lot. And if you have any question, please let me know. You can just type it in the chat box. I can just answer all of your questions, and hope you have fun.